Hey guys, this is Shivam. Today we will be dealing with the real option in the capital budgeting. Now, here you can see that why do we, what is the importance of this options? So, it is seen that in normal situations we have already done NPV. So we compare two projects, we see in which project the NPV is higher, through which we will get better returns in our future. But it is seen that in real practice managers would go for a project even though the NPV is negative. Now why is that? It is because they feel that initially maybe the NPV will be negative, but later if we would either expand the business, or if we would abandon the business, or if we would wait for some time, then we might get some positive value from that particular business. Now these three things, expanding, abandonment and waiting, are options that we can do with that particular investment. So that's why these are called options. Now the value that we are generating, that is making our base NPV as positive, for the that is known as option value. So if here is the formula, the financial NPV that we are interested in knowing would be the addition of base NPV, that is the NPV of the returns, plus the value that we are getting through options. Now uh, it is, in the example I said it would be negative, but the questions that we would be doing, it won't necessarily be having a negative NPV. Now we would be looking at some examples. Mainly we will be dealing with the abandonment and the waiting option. Now, for an example of abandonment value, you can refer to page number 258, question number 17 of your book. Now, this is the question. Now, here I'll take this again to my copy. I have written everything there, then it will be easy. Now, the number of units that okay, so the question says we are examining a project. Uh, we expect to sell 900 units per year at 35 net cash flow a piece. That is, it will be, you can take it as CPU contribution per unit, and you can take and this is the expected units. Now this will be, we have assumed it will continue till next 10 years. In other words, the annual operating cash flow will be 35 into 9,000, that will be 315,000. The relevant discount rates is 16%, and the initial investment required is this much. Now this is the discount rate according to which we will apply NPV, and this is the initial investment, that is in the year 0. Now the basic task, what it is saying is to ask to find the base case NPV. This is the simplest part. So as you know, I have written here directly. I am not writing again year 0, 1, 2, 3. It is because it's very easy. Now this is the initial investment. So minus 1350 again. This full will be the initial investment plus the NPV of subsequent uh, cash flows. Now here they have written that every year it will be 35 into 9,000. So it will be a same amount that we will be gaining for next 10 years. So we need not apply NPV in again and again. We can directly apply the formula of PVIFA. So what is the formula of PVIFA? The formula for PVIFA is, if we are supposed to get an amount C for say PVIFA at a rate of R for time t. So if we are getting amount C, then the formula will be 1 minus 1 upon 1 plus R to the power t whole divided by R. This is the formula. So I have done nothing, but I have multiplied this 1 by r in the here, and I have cut this, so this is coming 1 upon 0.16 multiplied by 1 minus 1 upon 1.16 to the power 10. This is PVIFA, this is our C in this case. So on solving this and subtracting it from this, you will get base case NPV. This is our answer. Now we will come to the option. Now for option, we have applied a method that is called decision tree. That is, we will analyze whatever possibilities or whatever options that we would be having once we go into this project. So here is D1. D1 is decision one that we take at year zero. Year zero says whether you want to make investment or not. Suppose you don't want to make any investment, then what will be your sales? Obviously zero. So what you will be earning? Nothing. But now you think of doing the investment. Now you see that actually you are getting 9,000 rupees, but 9,000 units for 1 year. But after 1 year, there might be that it might be that your assumptions are not correct. So, what would happen in that case? So, after 1 year, you will try to rethink whether this business was right or not. If you think that will be the revision stage, that will happen in the year one. This was year zero. You did your business for 1 year. You sold 900 objects at 35 rupees. Now you are coming to the revision stage. Here there could be two conditions. One, that you are selling your goods, a lesser number of goods, say 4,000, or your business might have an upward uh, profit of say 11,000 units. Now that will be a very preferential situation. We need not think much about it. But if we are not having it, if we are having say 4,000, then our decision might be to continue with it or to sell it. Now, when will you sell it? You will sell it when you will be having an option of selling it. This is our option that is given in the question. Now, I will take you to the question. Here it says after the first year, the project can be dismantled and sold at 9 lakh 50,000 if expected sales are revised uh, based on the first year's performance. When would it make sense to abandon the investment? In other words, at what level of expected sales would it make sense to abandon the project? So we are going to find that particular quantity. Then when should we abandon the project? So in the question, it is asked that how much quantity, at what quantity you will keep on producing and not switch. Now, in that particular case, say after this 1 year, we have already produced now 9,000 unit at 35 rate. After it, I would like to produce only if the NPV of say I get 4,000 units, say, but with this 4,000 units multiplied by 35 per unit for 9 years, I am going to calculate the NPV of this full thing. But if this NPV is less than the amount that I might get by selling my project, that is this, then I won't be producing this for the next 9 years. I'll sell it here because it is this selling it will be more profitable. So what I'll do, I'll equate these both. In it, I won't be giving any quantity here. So I will get till what quantity. So in this particular formula, I will not be putting Q, and towards the end I'll get. Now what is this formula? It is nothing but the PVIFA of, say in this case what I calculated. It was supposed that I will get this much because I am assuming that I will sell 9,000 units at 35 till 10 years. But here I am not sure. This particular quantity, what I am getting, I am not sure about it. So I'll take it as Q 35 multiplied by this PVIFA. Here now it won't be for 10 years, it would be for 9 years with the same interest rate. So here I did not put Q. I rewrote the formula. You will take this particular thing in division of the value that I might get if I abandon the project, and I will, and you would see that I will find Q to be this particular amount, 5,892 units. This is, you may say, the break even. Now, if this Q star, if suppose the actual quantity after 1 year, I have produced 9,000 units, but my research shows that for the next year I would be able to sell say 6,000 units. So will I be going on with the project? Yes, because 6,000 is greater than this Q star. But if it is less than this, say 4,000, then I'll stop producing and I'll go for selling this. Now this option being available is preventing me from keep on producing, even though I will be on in a loss situation, because producing 4,000 knowing that it will be unprofitable for me will be a loss situation. This particular option is giving me a value. Now in next question, which is a continuation of this question, we will see how this option creates a value. Now coming on to this, uh, abandonment. If in the previous problem, suppose you think it is likely that expected sales will be revised upward to 11,000 units if the first year is succeeded is a successful, and to 4,000 units if it was unsuccessful. Okay, this is a condition given. So this is what I have drawn, that after revision you might get an upward success and downward, what do we say, failure. So 11,000 and 4,000. Now the first question what it is asking, if if success and failure are equally likely, what is the NPV of the project? Consider the possibility of abandonment in our answering. So what it wants us to do is, it is saying equally likely. So what is the probability that I will be getting this much units? The probability is zero point 0.5. So whatever will be the NPV from this, I'll multiply it by zero point 0.5. What is the probability that I will be selling 4,000? It is again zero point 0.5. Now, as I have shown here, if we are producing 400 unit, we have two options: either to abandon it or to continue with 4,000. In the question they have given, and the logic says that we should abandon the project. Okay, in the question A part also it is said that you consider that you abandon the project. So we will do nothing but multiply this by zero point 0.5. Now the thing to be understood is that we are calculating initially this whole NPV at first year, not the 0 year. Okay, that 0 year calculation also we will do, but later. Now, CFAT, that is cash flow when in the upward case, when we are getting 11,000. So 11,000 units multiplied by 35 multiplied by the probability, that is zero point 0.5, multiplied by 4.61. This 4.61 is nothing but PVIFA for 9 years at a rate of 16. This thing what is written here, when you will solve it, you will get 4.61. This whole came out to be this. Now understand this, that this is not the full NPV. This is just zero point 0.5. This is the expected value. When it is already occurred, we take average. When we are talking about future possibilities, we take expected value. Now in this we will add the another expectation, that is, if I get 4,000 units, I will abandon it, get this amount, multiply this by zero point 0.5. As I am getting this amount at the end of first year itself, I need not discount it. Okay, so this came, adding these both. Now what, now this both I'll get at the end of first year. It in addition of it, I will also get the one that I will get by selling 9,000 into 35 units. Okay, it came out to be 31500. These all three things, 000, these all three things I'll get at the end of first year. Okay, but at the 0 year, what I will get, what I am investing, 135,000, but you will, four zeros, but you will see that these three are at the end of first year. This investment is at 0 year, so again I have to discount these three things for 1 year. Okay, so my net NPV will be mine. I am giving this particular thing as first, this as second, this as third. Now minus 1350000 plus, I have discounted this for 1 year, 1.16. What, first, second and third, because they were at the end of first year. Finally calculating it, I got the answer as, now it might be quite confusing, so I'm repeating this, that why am I discounting only these three things by 1.16? It is because I have to find NPV at 0 year, because I have not done any of this investment yet. I'm just doing a budgeting exercise. So all these three things I got at the end of first year. Okay, ₹9,000 मैंने 9,000 यूनिट्स मैंने ₹35 में बेची। उसका मेरे पास अमाउंट आ गया कब? जब मैंने साल भर के बाद बेच दी। उसके बाद मैं अगर अपना प्लांट पूरा बेच दूंगा तो उसके पैसे मेरे को कब मिलेंगे? 1 साल के बाद। उसके बाद अगर मैं 11,000 यूनिट से बेचने लगता हूं तो उसकी एनपीवी में कब निकालूंगा? अभी उस पर्टिकुलर ईयर पे। तो आई हैव डिस्काउंटेड इट फॉर 9 years, नॉट 10 years. But ultimately, I have to discount it to 10 years also because my NPV exercise, I am where am I standing on the timeline at the zeroth year. So after 1 year is no value. So that's why this remains this, but these three have to be again discounted for 1 year. So 1.16 after discounting, I have got the answer as positive 96056.03. Now this is the answer when I have the option. Now suppose in this particular condition I did not have the option of selling it, then I might have incurred some loss. So that's what the second part asks us, that what is the value to the option of abandon. So for it, what I will do is this particular part will remain same, but this particular part, only this particular part in this question will change. In place of this 9540, I will just write 400 units multiplied by their price, 4,000 units multiplied by their price, multiplied by the probability that is intact to them. Now this particular thing I'll get for 9 years. The plant, when I will sell the plant, I was getting it on the first year itself, but this I'll continue for 9 years. So again I'll multiply it by PVIFA 3.5, uh, 4,000. PVIFA for 16% for 9 years. So it is again 4.61. So this whole thing will be replaced by this. Else everything will be same. I have done it here. I got some value. Again, I added these three things, subtracted this. I got this amount by adding these three things. I discounted it by 1 year. My NPV came out to be negative. In this case, it was positive when I had the option of selling it. In this case, when I was bound to sell it at 4,000 units, my NPV came out to be negative. Now, what is the value of option? So, value of option would be the NPV in the option 1 case minus the NPV in the option 2 case. Sorry, not option when I did not have an option. So, 1 minus second. So this was the value in option when I had option minus. Now the NPV is actually negative. So again minus. So when I'll add this, this is the value of option. Okay. Now we had three options to deal with: expanding, abandonment, and waiting. I'll be dealing with these both. Abandonment we have done. Now the waiting option. For waiting option, we can look at the example given on page number 256, question number 5. Now let's read what it says. Your company is deciding whether to invest in a new machine. The new machine will increase cash flow by itna per year. So this will be my C that I will be getting for per year basis. Now you believe the technology used in the machine has a 10 years life. In other words, no matter when you purchase the machine, it will be obsolete 10 years from today. That is, say you buy a Windows XP, Windows 8 software. Now, its life, how much would be its life? It would not be more than say 1 or 2 years, because every 2 years a new OS will come. So in that case, this machine might get obsolete in 10 years. uh, Another thing related to it is, now taking the example of Windows 8 itself, every year you will see its cost will get down. Is something getting depreciated? No, it's just that the technology is old. That's why its value will reduce. In the similar way, in this particular case, the machine is currently priced at this, that is 22 million, 2.9 million. the cost of the machine will be declining at this per year until it reaches this. So each year 2,10,000 would be reduced from its price because that it is getting obsolete day by day, and but it will be stagnant at this much price for some years. Now where it will remain, if your required return is 9%, we'll be using this for discounting. Should you purchase the machine? If so, when should you purchase it? Okay, now so how should we proceed? So we will find the NPV for first year, second year, third year. How that I am buying it at this particular year, or I am waiting for 1 year, I am buying it the next year, or I am waiting for 2 years, I am buying it for 3 years. So I will calculate NPV in each cases. Now, in the first year, say I will buy it for 2.9 million, plus the I will be getting 4,75,000 per year of saving, multiplied by the PVIFA for 10 years at 9%. So I will do 1 upon 0.09 multiplied by 1 minus 1 upon 1.09 to the power 10, because the life of the machine, it will get obsolete in 10 years. I'll be utilizing this particular benefit for 10 years. Now this NPV is coming to be 149500. Now I think no, I should wait. So after 1 year, the value will of this particular machine will be reduced by, as we have already seen in the question, by 2,10,000. So I'll reduce 2,10,000 from this particular amount. I'll get 2.69 million. Okay, so again I will calculate minus 269,000 plus 4,75,000. But here you will see that PVIFA
9 years.
will be different, because now I will be calculating it for 9 years, not 10 years, because 1 day is less, 1 year is less. So here you will see the NPV is coming this. You can see that in the second case the NPV is greater. So waiting has actually produced some value for me. So the same we will do for, say, for second year, when I'll be buying it at the starting of the second year. It will again reduce by 2,10,000. Again it will reduce by 2,10,000 in third year, but after that it won't be reducing, because it is given in the question that after it will stay at this particular amount for rest time, for rest years. So you will see that at 248,0000 the NPV was coming to be 146750. For 227,000 it was coming 119250. Now as this particular amount is not reducing, then here each year my NPV will be less, because each year this particular PVIFA will keep on reducing. So we need not calculate anything further, because it will be anyway lesser than 1,19,250. Okay, so we will be comparing this particular data. Now it is evident that in this particular question, in year 1, that is after waiting for 1 year, I am getting the maximum NPV. That's why the answer of this particular question will be that if your required rate of return is 9%, should you purchase the machine? Yes, we should, but when? After 1 year. So we have concluded the abandonment and the waiting option. Thank you for patient listening.